Howdy! I've spent a few days reading the code of a game glued with determination, Undertale. One of the most infamous games among programmers, and at the same time, one that sold like over 5 million copies. I mean, like, when it comes to code quality, it's a common opinion that Undertale is horribly written. And you can even find plenty of videos here on YouTube made on this topic. However, most of them haven't actually read through the code. And I can't blame them. The code of Undertale is kinda hard to read, as it was written in GML, which is a quite limited language that was specifically made for GameMaker. But it also means those overviews contains a sheer amount of inaccuracies. And you probably heard about, quote-to-quote, a huge single file that contains all of the dialogue in the game. Well, in reality, the file everyone refers to contains like 1/6 of the all dialogue lines in Undertale. Furthermore, the developer of the game, Toby Fox, actually managed to write a pretty clever old-school text engine with Goth interpreter pattern in his code. And there is like tons of Easter eggs and funny stuff inside. He even managed to make a joke on data miners. It was an unused message saying, "You feel satisfaction that your hard work reverse engineering the encryption of the Xbox One has paid off." The guy seems to like adding notes like this here and there. Even on his website there was a hidden message. Jeez, now that's what I call a true determination. We're also going to look at the Undertale's code architecture, funny code tricks, infamous self-removal of the game's EXE file, how random works, what's the entropy, and how random events happens. And of course, the save load system, and how exactly characters like Flowey remember you even after you load the game. And with that being said, let's start with how Undertale startup code works. Okay, in Legacy GameMaker, most of the code was stored inside an XML-like files with GMX extension. That's because you were not supposed to use an external editor to write code. So probably the entry point for the game is an obj-time file. The code inside is sorta jack of all trades. It contains a joypad config loader, a joypad to keyboard remapper, and a keyboard input polling. At the same time, it's a global stopwatch, full screen toggle, dialog skip, a quit game handler, and even a hidden debug console, all in the same place. Of course, obj-time also contains a code for the game start event, which ends up calling a function named scrGameStart. That's where things gets initialized. And I have noticed a few genuinely unusual things here. At the very first line, it calls a randomize function. It's used to seed the random number generator. Without it, every launch of the game would produce the same sequence of random numbers. By the way, in case you are curious, the entropy is the current time. Thing is, that's the only place in the whole codebase where this function is called, and you will not find any other RNG seeding functions either. Now, if you're a programmer, you already know what that means. Apparently, RNG state is never written into the save file, thus Undertale doesn't have any sort of a manual seed management. Honestly, it sounds quite ironically. The game all about determination happens to be non-deterministic. Anyways, this code also contains initializers for things like player HP, gold, XP, and tons of other values. For some reason, it also reserves 128 simultaneous audio channels and sets 512 flags to the value of 0. Funny enough, those flags are not named, thus you can't tell their purpose right away. However, as far as I can tell, GML does support enums, which means it could be a result of a compiler optimization. Now, if you ask me, Undertale is mostly famous for its iconic and hilarious dialogues. Thus, Toby Fox probably spent tons of his time writing a good text engine. And it could be that I'm the first person who ever discovered this, but Undertale contains a well-written Gang of Four interpreter pattern that uses an old-school trick to process dialogue lines. It's a small expressive language that uses an escape characters and bunch of reserved characters for a special formatting and commands. Say, a backslash plus a letter sets a text color, or switches the speaker's facial expression. A caret plus a number pauses the typewriter, an ampersand is a new line, a slash ends the page, a percent advances to the next one, etc. Take this line as an example. \E1 is used for changing a speaker's facial expression. Then it renders greetings text and breaks to a new line. Then again it renders I am Toriel text, and then a pause happens for 20 frames, which is approximately 1 second. After that it renders caretaker of the ruins text. A slash means it's the end of a dialog page and the percentage means a page break. Now, when I say old school, I refer to a well-known approach that exists like since 1970s, the same way JRPGs like Final Fantasy VI on SNES wrote dialogues back in 80s and early 90s. And even today, we use pretty much the same trick, just in a more modern way. That's how Markdown and BB code work. Okie dokie, but how exactly the dialog lines are stored inside Undertale's code? Not gonna lie, that's where things get messy. Basically, inside that STR text file, we can find probably the world's largest dialog table. It contains a switch statement with more than 400 cases and more than 5,500 lines of code. However, it's a common misconception that this single file covers all the dialog lines in the game. In reality, Undertale contains approximately 15k dialog lines, but only like 10 to 15% of all of them are stored inside this STR text file. For example, a Papyrus NPC phone calls takes about 8% of the dialog share and lives in a dedicated file called strpopcall.gml. The same goes for Toriel phone calls, for item use messages, for battle intros, etc. And the most dialog share, which is like 74%, is actually inlined across hundreds of different files. What makes it hard to extend and edit is the lack of any dialog editor. There is also no JSON files used for this, not even a CSF table, which is a common way to store translation strings. That said, the code also lacks of any localization functions. And it was actually a deliberate choice of the developer and not the limitation of GML, because it does support both JSON and CSV files. Thus, it could be used to properly store dialog lines and enable kind of an easy way to introduce localization to the game. But it wasn't. One thing I also noticed in the code is a funny list of names, which is used inside the character naming screen. And if you type Frisk as your player's name, the game warns you it'll be a hard run. Type Toriel and it'll gently tell you to pick your own name. Type Gaster and the game will restart. There are roughly 24 of hard-coded names like this, with different effects and consequences. However, I cannot show you all of them, because Toby Fox literally left a note in the code in case someone reads it. In short, he says that part of this game's charm is the mystery. Thus, he asked not to post this code online or it may ruin the secrets. And while I'm 100% sure it's already posted somewhere online, it still makes me wonder how many people who also read the code are actually followed this request. Anyways, instead of this, I will uncover another secret of Undertale's code, and it's all about random encounters. Spoiler, they aren't really random. There is a special counter in the code that increases while the player is walking, although it's not a step counter. At Undertale's 30 FPS, 36 means 1 second of a constant walking. Standing still, talking to NPCs or opening the inventory effectively pauses it. For example, there is one rare enemy in Undertale that literally requires 2 minutes of constant walking in a certain area for the encounter to trigger. And those random encounters works pretty much the same way. Once a counter crosses an area-specific threshold, an encounter happens. But the threshold is not constant, it gets longer the more monsters player defeated in the area. And once again, what makes it hard to edit and extend is a lack of a data-driven approach. Every area has its own like 50 to 100 lines of code file with its own copy of the dispatch table, its own counter values, its own hard mode branch, etc. And I mean, things like this should be data-driven, whether it'll be a JSON file or yet another CSV table. Okay, now let's see how the save and load system works in the code. It's interesting because saves coming is actually one of the core mechanics in Undertale. So when you load a save file, somehow it keeps a record of your previous timelines, and it allows characters like Flowey to haunt you with the truth about what you did in the past. The implementation is quite simple though. A file named str_save_progress is all responsible for saving the game state. It writes a plain text file without any encryption. A save file itself contains approximately 550 lines, with the player level, name, HP, gold, XP, etc. It also contains that huge 512 flags array. But what makes it to stand out is that alongside the save file, it also writes some special values to a special Undertale.ini file. It is this file that makes Undertale characters to recognize what player did in the past, because it persists across deletions, untouched by the save management. So even if you reset the game, only your save files will be deleted, but the ini file is still there. Thus, when you start a new game, Flower will still remember who you are and what you did. In game development, it's called a meta-permanence or a meta-progression. It's a data that persists across multiple play sessions and even across different save files. Although Undertale definitely took this mechanic to the next level. And two more interesting things I found in the code is all about how random things happens. First, there is a special flag in the code called a fun value. So when you start a new game, it rolls a single integer between 1 and 100. A result gets written to the ini file and never rerolls again, unless you do a true reset. Further, in the code, this value is used as a gate for a certain in-game events. For example, if the fun value is exactly 66, a geyser door will appear in the waterfall area, and when you enter this area, a fun value then changes to 0, which means you cannot enter it again. Another cool part of random things in the code is how a runaway math works. Inside the file str_runaway, we can find a code responsible for this. Basically, it's 50% chance on turn 1 plus 10% per subsequent turn. And for a hard mode, it's a random chance plus the same 10% per subsequent turn minus 1. However, if the player is still wearing the starting bandage armor and it's not a hard mode, then fleeing always succeeds. This way the game allows for new players to always flee if they want to. Another thing that certainly deserves our attention is an infamous Undertale self-removal code. Apparently, at the end of the game, the player is given a choice to destroy everything. It's a special ending, and if you choose this route, the game then crashes. And when you start it again, only the black screen appears. And even if you try to reinstall the game on Steam, it will not help, because the game secretly creates a special file named System Information 962 and then pushes it to Steam Cloud. So it will often re-download that file, making the consequences of your choices in the game to feel permanent. Honestly, it's a brilliant piece of psychological programming. The game breaks the fourth wall to convince you that there is no other way around. But the best part about it is that at first it was meant to actually delete the EXE file of the game. And we can see the remains of the code responsible for this inside OBG GameShake file. This code tries to remove Undertale.exe file. It's not commented out and not gated behind a debug flag. However, it doesn't work either, even though at first glance it looks like a totally working code. And I can think of multiple reasons behind this. First of all, Legacy GameMaker was not sandboxed, so probably by the time Toby Fox wrote this code, the path resolving was pointing to the game's actual install directory. Thus, it was the correct path to the game's exe file. But then he switched to GameMaker Studio, and as far as I know, in this version, the file API was now sandboxed. So relative paths was resolving the GMS working directory instead of the install directory. And of course, whether it would succeed is a separate question, and probably the answer is no, it was never a working code, simply because Windows wouldn't let you to delete a running executable whatsoever. And I have a question for you. How exactly you can make something like this to actually work? A classic workaround on Windows would include a use of a move file X that deletes the file on next reboot. You can also spawn a self-removal batch script that loops until the parent process exists and then deletes the exe file. One more thing you can do is simply rename the executable. Windows API holds an exclusive write lock, but when you rename a file, technically it's a link operation. It restricts other openers but not the executable itself, because it already holds the handle. By the way, it's a common self-update trick in programming. The running.exe has its image section mapped, which prevents deletion, but the directory entry itself can be renamed without any issues. This way many popular apps gets updated, such as a Google Chrome browser. Update the code, renames the running binary, drops the new one in place, and the old file gets cleaned up on next launch when no process holds it anymore. A clever solution every programmer should know about. Funny thing, the developer of Undertale actually did use this trick to rename games.exe, but it was inside another file called OBG Asgore Last Cutscene, which is apparently a final boss battle. The code here renames Undertale.exe to Flowey.exe, and it only gets renamed back after the player defeats the boss. And at least in theory, that's how it's supposed to work. In reality, once again, a GameMaker file API sandbox enters the chat, meaning this code still not works because it points to a totally different directory. However, it also makes a sneaky save file to slot 8 with current room set to 319 that is apparently used for the fake save corruption joke. Thus, the whole idea still kinda works in the game. And just like I said before, the code of Undertale also contains like tons of jokes and funny stuff. Take a file OBG essay stuff as an example. It's a mini game that occurs during Metaton EX boss fight, where he asks you to write an essay about what you like the most about him. And the code that is responsible for analyzing your answer is quite hilarious. It actively uses things like string length and string pass, and even contains a small profanity detector. Say, if your essay contains only one character, Metaton will assume you are speechless, and if it contains exactly 2 characters, then he assumes your answer is, well, concise. It also checks for substrings like adorable, stunning, elegant, etc. And if your essay contains a bunch of them, then the boss gets speechless himself, because apparently you have completely captured how beautiful he is. The code also checks for insults, and if your essay contains any of them, he says that the essay is supposed to be about him and not about you. Anyways, the code here is quite simple, but as I said, it's quite hilarious. Finally, when it comes to code quality of Undertale, for some reason, many of those who calls it a bad code doesn't consider a wide variety of GML limitations. Think of this. There was no structs, no tuples, no closures, no namespaces, no modules, no try-catch, no error propagation. You couldn't even use a separate code editor, and all of the code was shipped inside an XML-like files. Geez, GameMaker barely had any of the code files in options and 0 refactoring tools. You couldn't even find all the references across the project that worked reliably. Let that settle in for a minute. Of course, it doesn't excuse every single choice in the code. For example, dialogues could use a CSV table or a JSON file, and the same applies to any other huge if-else statements or a switch case block. It also could benefit a lot from dynamic data structures, enums, named constants, and inheritance, but most of those could be optimized by the compiler, thus one cannot straight up tell if they were used or not. I mean, if you ask me, sure, the code is not perfect, but it's also not that bad either. It's a shipped code that works in the first place, which is a great thing, because it means that you don't need to write a perfect code to make a good game. And hopefully it'll give more confidence for beginner developers out there. And with that being said, make sure to subscribe to the channel, smash that like button and write your opinion in the comments. Thanks for watching, I'll see you in the next video.